For section 12.4, we're going to start talking about something called the normal distribution, okay? Let me find my pen. Unfortunately, there's a lot of description in this section of notes, so there's going to be lots of words, lots of talking at first, then we'll get into practicing some of this stuff. So we do need to recall a few things. We've already talked a little bit about ways to organize data. And so back in section 12.1, we talked about organizing data, and one of those ways was doing a frequency distribution. Okay, so a frequency distribution basically takes your data set and it organizes it based on how often a data item occurs in that set. Okay, so you could have this frequency distribution, which shows different data items or different classes or groups of data items, how often those data items appear. And then we had a graph called a histogram, which was similar to a bar graph that kind of shows that distribution visually. Okay, so as a kind of a quick recap, we have a distribution shows how data values are spread out or arranged. So again, with a frequency distribution, we look at how they're spread out based on like how often a data item occurs. Okay, for instance, if we measure everyone's height in the class, some people will be tall, some will be short, and most will be somewhere in the middle. Okay, so if we were to look at a group of, let's say, 50 kids and look at their heights, we would have a bar graph that looked probably, or a histogram rather, that looked probably something like this. Okay. We'll have some tall kids, we'll have some short kids, but most of the kids will be somewhere in the middle. Okay. So that's kind of what we were doing with a frequency distribution. The height of the bars represented how often that data item showed up. Okay. Now, a frequency distribution, we've already talked about it a bit. A frequency distribution is one way to arrange data based on how often a data item or a group of data items appears in a data set. And again, the graph is called a histogram. Okay, so just keep all of that in mind as we move forward with this thing called the normal distribution. Okay, so for topic one, we have understanding the normal distribution. So for the definition, it says the normal distribution is a special and theoretical. You have to understand that this is what we would assume would happen in some theoretical situation. So the normal distribution is a special theoretical type of frequency distribution that models real world situations. This is used to estimate probabilities, compare different data sets, and make predictions about populations. Okay. So remember, if the normal distribution is a special type of frequency distribution, then we would be looking at basically a special type of histogram. Okay. So if we did look at that special type of histogram, we would have a situation that is bell-shaped and symmetrical. So when we talk about something that is bell-shaped, it looks like this. That's what we mean by bell shape. And we assume it's symmetrical, as in if we were to fold this down the center, and of course my drawn version is not symmetrical, but pretend, squint your eyes if you must. But if we were to fold this distribution in half down the middle, the two sides would meet. Okay, so in the normal distribution, it's a theoretical distribution that is bell-shaped and symmetrical. The mean, which we already know is kind of just the average, it's not kind of, it is the average. So the mean of the data set is going to be the center of the distribution. So this value in the middle, right here, this would be the mean. Okay. And most of the data values would be clustered around that. So you can see the bell part, the little curve that goes up, that's going to represent the bulk of your data. Remember, this is really just a frequency distribution. So data items close to the mean have the highest frequency. Data items further away from the mean have a lower frequency. They don't occur as often. Okay. Now, the spread is described by the standard deviation. So we talked about the standard deviation in 12.3. So remember, standard deviation is a way to measure the dispersion or the spread of the data set. And it basically looks on average, how much does each data item differ from the mean? So when you're dealing with something that is some data set that is normally distributed, so in theory, it would be normally distributed, we always look at a mean and a standard deviation. That's how we describe our set. Okay, so if you have a small standard deviation, that means data items are going to be on average pretty close to that mean. Okay, your curve would be kind of tall and narrow. That small standard deviation is going to say a bunch of those data items are really, really, really close to the mean. Okay. Now, for a larger standard deviation, the shape of your curve is still going to be this bell curve, but it's going to be wide and flat. All right. So the standard deviation is going to dictate the shape of this normal distribution. It'll still be bell-shaped, it'll still be symmetrical, but some of those bells will be tall and narrow, other bells will be kind of flat and wide. Okay, and that's all going to depend on how spread out your data set is. Are data items really close to the mean, generally speaking, or are they much more spread out? Okay, some examples, some real world examples that we will look at that can be modeled with the normal distribution are heights of people, test scores, IQ scores, and blood pressure. Okay, so those are things that are normally distributed. One thing that is really important to point out is when we're looking at a frequency distribution and a histogram, oftentimes we're looking at a sample. So we have to go way back to 12.1. The sample is a subset of the population. The population is every single item that you're looking at. So if we were looking at, for example, adult male heights in the United States, it would be almost impossible for us to find every single adult male height. Okay. It would be hard to track down every single person that lives in the United States that's male and check their height. Okay. So instead, what we'll do is we'll look at samples and we'll say, based on this sample, this is what we think would happen with the population because we're saying adult male heights are normally distributed. Meaning, if in theory we could get the information for every single person in the population that fits the criteria, then we would have this normal distribution. So we'll use a sample to make predictions about the actual population. Okay. Now, to give you kind of a visual of how this happens, we have these 4 histograms right here. It says below is a histogram of adult male heights in the US. Notice that as the sample size increases, we start to see a bell-shaped curve. This is a symmetric curve. This symmetric curve is approaching what we call the normal distribution. I have a little typo right here. So this, whoops, not there. This is a little typo. That should not be there. So this symmetric curve is approaching what we call the normal distribution. So in this first picture, graph histogram A, we have a sample of 100 men. And you can see if we were to draw a curve, it's definitely got that curve shape to it. It's not perfect, but it's there. We can see that this is kind of similar to what we would say is a normal distribution. Next, we say the sample size increases. So let's say we're looking at 10,000, okay? So looking at 10,000, you can see this data is starting to better fit the curve. The data size is going to increase again in graph C. So let's say we're looking at like 100,000 or a million. Okay, so you can see that we're now getting much closer to this theoretical, perfectly symmetric bell curve. And then for sample D or graph D here, instead of looking at a sample size, we're going to say, hey, assuming we had information for the entire population, we would have this perfectly smooth, symmetric, pretend that's symmetric anyway, this perfectly smooth, symmetric bell curve. Okay, so as your sample size increases, you're approaching what we would say is normally distributed or a normal distribution, and that would represent the population, every single person, object, thing that we're looking at. Okay, so there you have it. As the sample size increases, the shape of the graph becomes more and more symmetric, which indicates we're going to look at something that would be normally distributed. All right, couple of notes here. Note 1, for graph D, we have the idealized or theoretical version of a frequency distribution that models the height for the whole population. So again, we're looking at adult male heights in the US. That would be assuming we got every single adult male height recorded and organized in this frequency distribution. Okay. Note 2, in a normally distributed data set, the mean, the median, and the mode are all exactly equal, and they are this middle value. Okay, so the mean, the median, and the mode really truly do represent the data item that falls in the center of a normally distributed data set. Okay, so I know that's a ton of words, that's a lot of description, but there we go. Okay, so that is the normal distribution in all of its glory. Okay, when we come back in the next video, we're going to look at something called the empirical rule. So it's a way to kind of look at percentages of data that fall within a certain number of standard deviations from the mean.